This is R.D. Sharma Solution, Class 12, Chapter 8. Solution of simultaneous linear equations. We are taking the MCQs, multiple choice questions. So before we go ahead in solving this MCQ, let me tell you there are certain prerequisites. You need to know A inverse, A transpose, multiplication of matrix, adjoint of matrix, and the determinant of matrix. These are all the prerequisites. If you are aware of all this, then you can easily do all these questions. Okay? Now, we have the system of equations given here, and all the questions which are coming up are like this only. So we have to find out whether it is a unique solution, no solution, an infinite number of solution, or zero solution as the only solution. So now you see, I am just concentrating upon the determinant and how we are going to form the determinant, because this is x plus y plus z equals 2, 3x minus y plus 2z equals 6, and 3x plus y plus z equals negative 18. This is the form of ax equals b. So the most important thing is everything depends on determinant of a, whether it is equal to 0 or whether it is not equal to 0. So that will decide all these options which are coming in the later questions as well. So how are we going to make the matrix? This is the matrix. So the solution will be ax equals b, x inverse will be, x will be taken here. So x will be a inverse b. So I am writing the coefficient of x, y and z. Here it will be x, y, z. And on the right hand side we'll have the constant value 2, 6 and negative 18. Okay. Now the basic is to find out the determinant of a. Determinant of a will decide everything. Okay. So let us find out the determinant. I am taking the first row to open it, 1, minus 1 and 1. So for 1 it will be negative 1, 2, 1, 1. For 1, 3, 3, 2, 1. For last one it will be 3, 3, negative 1, 1. So it will be minus 2. So it will be negative 3. Then we have 3 minus 6. So negative 3 into minus 1 is plus 3 here. Here we have 3 minus of minus 3, 3 plus 3 and 6. 6 into 1 is here, 6. So this is going to be a value 6, which is actually not equal to 0. And since I said this determinant of a, when it is not equal to 0, these given system of equation, they have a unique solution. So what is the correct option? The A is the correct option. So I hope you have understood this. First, determinant of a. The number of solutions of the system of equations, the same thing. So we have 3, 2, 1, 0. So ax equals b, because in order to find out, we have to do that. But you don't have to calculate everything. Why? Because determinant of a, if it is not equal to 0, unique solution, we have already seen. But if the determinant of a is actually 0, then you have to check one more thing. You have to move a step ahead. That is the adjoint of a into b. So adjoint of a you have to find out and multiply by b. That's why I was saying adjoint of a is a prerequisite. You must know it. So let me just show you here, because making equation and solving, we have already seen all this. So coefficient of x, coefficient of y, coefficient of z, that will form the A matrix. X is of course x, y, z. So when we find out the determinant of A, I hope and I presume you know the determinant of A, how to find out. It is going to be 0 in this case. So when it is going to be 0, you have to find out the adjoint of A. For that we have to find out the cofactor matrix. Then we have to take the transpose of that cofactor matrix, and that is going to be adjoint A. Now we already have a b here. What is b? B is your 715. So adjoint A into multiplied by B, this you have to find out, and that will be a negative or a positive, means negative or non-negative value. So we have 157, it is not equal to 0. When determinant of A is 0 and adjoint A into B is not equal to 0, the given system has no solution. So here we have X, A is also given and B is also given, and also AX equals B. So there are proper values, so we have to calculate the values now. Okay, so we have A, X equals B, and what is A here? It is already given in the question: 1, 2, 3, -1, 0, 2 and 2, 1, 1. So determinant of this, I hope you will be able to do it, that is going to be 5 in this case. Then we'll find out the adjoint A. Cofactor matrix, transpose of that divided by the determinant, you will get the A inverse. Multiply by 314, you will get proper value, which is also given in the answers. So the answer is this -1, 2 and 3. I think it's C1. Just recheck it. It's C option is the correct answer. The number of solutions of the system of equations. So same thing you have to do. But since the determinant of A is coming as 0, in this case it is coming as 0. So adjoint A will be finding and will be multiplying it by the B. So 715 is B, and you will see that the final result is not equal to 0. That means this given system of equation, they are inconsistent. So you will just say it has no solution. Here also the same thing. Here we have K, some K. So what do we do? So this system of linear equation has unique solution. When? So what we'll do is determinant of A, unique solution. See, for unique solution, determinant of A should not be equal to 0. So I'm writing the coefficient of X, then we have coefficient of Y, coefficient of Z. So we have these coefficient of X, Y, Z I am writing, and then let us take the determinant 1 and -1 and 1. I am using the first row to open it. You will get 1, 2, -1k. Now this one will be 2, 3 and -1k, and this last one will be 2, 3, 1, 2. So do you get k and minus is plus, so k into 2 -1, 2k, and minus become plus 2k plus 3. Then we have third one, 2 to the 4, 4 minus 3 is 1. So what will be the case? See, k plus 2, it will be negative. Okay, negative. So minus 2k minus 3. Minus 2k minus 3. So let me just change it. It is negative. So you get this is k, and 2k minus 2k is minus k, and 3 minus 3, of course 0, so you can just cancel. Minus k is not equal to 0. So k is not equal to 0. That is your answer. K should not be equal to 0. K equals 0, this is the answer here. K should not be equal to 0. Now consider the system of equations. Now the system of equation is given, but the right hand side is 0, 0, 0. So if we have this equals 0, the determinant of the coefficient of x, y, z is equal to 0. We know ax equals b, but here b is 0. So what will we do? See, determinant of a is 0. Since b is also 0, that is 0, 0, 0, the right hand side, if you see, this determinant of a is also 0, which is given in the question, and b is also 0. That is, we have the more than 2 solutions. That is the answer, because one trivial, one non-trivial is not possible. No solution. Only trivial solution 0, 0, 0. That is not possible. So if the determinant of a is 0 and adjoint of a into b is 0, then the case is different. The system is consistent and it will have infinitely many solutions. So in this particular scenario, the system of equation has more than 2 solutions. Okay. So you have to know when determinant of A is 0 or not 0, and then adjoint of A and B is 0, not 0. All these cases we have discussed in a stretch in previous discussion. This is MCQ, simple MCQ. So there will not be a proper, it will not take that much of time. So there will be simply all these scenarios which you have to see. Let A, B, C be positive real numbers. The following system of equations in X, Y, Z. Now, these are not in the proper format. We cannot do it directly. We cannot do it as X, Y, Z, the equation we just saw. So we have to change a bit. Assume x square equals x. I am saying assume it. X square can never be equal to x. That is not the case. Just to make it as x, y, z, you can take it x square as p, y square as k, and z square as r. It's up to you. I'm just saying I'm pretending x square is x because it is not playing a very vital role in the solution. You'll just see. Assume this x. I'm writing x square, y square, z square as x, y, z. Okay. Now, if you want, you can have it as p, q, r, or whichever alphabet you know. So I'm writing it here. The coefficient of x, y, z, that is x square, y square, z square. 1 by a square, 1 by a square, minus 1 by a square. Coefficient of y is 1 by b square, minus 1 by b square, and 1 by b square. 1 by b square. It is 1 by b square. I'll just change it. Then we have the third one, which is the coefficient of z. You have to see. What is the coefficient of z? C square. 1 by c square. So negative 1 by c square, 1 by c square, 1 by c square. So this is your A matrix. Now this is x, y, z is your X matrix, and of course B matrix is 1, 1, 1. This is already given in this question. So 1, 1, 1 is the B matrix. In this case, if you want to find out the determinant, because determinant of A will decide the answer. So determinant of A will be what? Let me take 1 by A square, constant away from here, common, 1 by B square from the second column, and 1 by C square from the third column. What is left? 1, 1, minus 1, 1, negative 1, 1, and negative 1, 1, 1. So let us solve this. So 1, minus 1, 1, 1, 1, then we have minus 1. I am opening it using the first row. Okay. So first will give you negative 2. The second will give you negative 2. And the third one will give you 0. So when we add this, it will be negative 4 eventually. So the whole idea is that this question doesn't fall into the category of XYZ, but still make it in the form which we know. And the form which we have made it as XYZ, like that. Okay. So after doing this, what do we see? We have to find out whether determinant of A is 0 or not. Is equal to 0 or not. The determinant of A is negative 4 divided by A square into B square into C square. This shows that these given system of equation, they have a unique solution. Okay, these have a unique solution. You have to, the second option is correct. You have to take the second option. So this type of question are generally being asked because these are not straightforward. For the system of equation this, what will be the answer? For that you just have to see the determinant of A. Okay. So determinant of A is what? Compute it. In this case it is going to be 3, which is not equal to 0. So you can just say that this given system of equation has a unique solution. There is no solution, none of these, and this will not be an option. So just choose this option. The existence of unique solution of the system of equations. So you have this three equation, and there is next question which is also for exactly like this. So just understand this. So we have 1, 5, 2, 1 minus 1, 3, and z is 1. So mu and negative 1. So we'll find out the determinant of it. What is determinant of A? I am taking the first row. So 1, then we have the negative 1, and then 1. So I'm just rechecking that whether the values I've taken is perfectly alright or not. So we have 5, 2, mu negative 1. Then we have here 5, 2, negative 1, 3. So it will be 1 minus 3 mu. Here we have negative 5 minus 2 mu. And the third one plus 1. So 15 plus 2. So 1 minus 3 mu, and if negative is there, just change the sign. 5 plus 2 mu plus 17. So 17 plus 5 plus 1 is going to be equal to 23. And this is going to be 2 mu minus 3 mu is negative mu. So 23 minus mu is not equal to 0. Mu should not be equal to 23. So the solution is only depending on mu. That is what you have to just say, that only it is dependent on mu. That is the answer.